Hey guys, welcome to our channel Code is Arcade. This is Ashank David, and in today's video we are going to talk about pointers in C. Now this video is related to all the topics on the concepts which are there in the VTU latest syllabus which we are following, and in this video we will be covering everything about pointers which is there in your syllabus. So we are going to start by what is pointers, and then we are going to talk about the types of pointers and how we can pass the pointers to the functions. Now let's start. Now before I start with this video guys, I would like to ask you people to please like, share and subscribe to our channel Code is Arcade, and don't forget to press the bell icon so that you won't miss any future updates. Now without any further ado, let's get right in the topic. So we need to first understand what exactly is a pointer. The program that I have written here is to explain you about that as well. So let's understand about first thing, what exactly is a pointer. What exactly is this pointer? So what is pointer? So pointer is also a variable. Pointer is also a variable which holds the address of another variable. So you can see that here I have created a variable. This is how you create a variable int I equals to 50. So now this is a memory location, and you know this, that whenever we create a variable, what is a variable? A variable is a named memory location. When we create a variable, the memory is allocated with some name into our RAM of our system. Now when the memory gets allocated into our RAM, it will have its own address as well, and that type of address could be stored inside a pointer variable. So let us understand about this program here. So first, what was a pointer? Pointer is a variable which holds the address of another variable. So pointer in itself is a variable. It has its own memory allocation also, and it will have its own address as well. So in this case, let's understand about pointers in depth. So I have a program to explain you here. I have a program here where I have created a variable int I equals to 15. Now when this variable is created in the computer's memory, this block is created where the name of the memory is I. As you can see, I, and the value is stored 50 inside it. And because it is a named memory location, it will have its own address also, and those addresses looks like this: 0x64FEBC or something like this. This is a hexadecimal value. So addresses of a variable are stored as a hexadecimal value. But if I take an example of hexadecimal values as the addresses in this video, it will get too much complicated. So I don't want to confuse you guys. So rather than this address, I'm going to take some random number 2179. 2179, let's imagine that's the address of this I variable. So now this is a normal variable. This is how your variable looks like when you create the variable for the first time into your memory, into your RAM memory. Now if I want to store its address, what I can do is I can create a pointer variable. So what I can do is here you see in this line number 5, int star ptr. You see this? This is a pointer. This is what? It's a pointer. And what type of pointer it is? Wild pointer. So now we need to understand how this pointer is made. So to create a pointer, usually what do we write is, we first write its data type, so int, then we write the star, and then we write the pointer name. Now there are three ways that you can declare a pointer. So first we write the data type, then we write the star, and then we write the name of the pointer. This star can be in between int and this ptr. So there could be some space here also, there could be some space here also. And this is one way of declaring the pointer. Another way is that you can give a data type, and then you can just put a star right next to the data type which you have written here. And then after giving some space, you can write this ptr directly here. You understood my point? So now this is another way. Or if you want, what you can do is you can shift this star here, and this is the third way of declaring the pointer. In this example, I have taken the star just next to the name of the pointer, and this is how we declared it. This is one way of declaring the pointer. So you can declare the pointer as you like. So as soon as you declare this pointer right here in this place, what happens in the computer's memory is that another box is created. This another box is created. Why? Because this is another variable in itself which holds the address of another variable. In this case, the name of this memory allocation is ptr. And because it is a variable on itself, it will have its own address also. And just like how we have taken the address as 2179, here we will take the address as some random number 3117, maybe take a random number. Okay, so now in this case, here this PTR is having this address, but this PTR is not holding anything but some garbage value. Some garbage value would be present here. When a garbage value is present inside an empty pointer, a pointer which is declared just, which is not initialized yet, those type of pointers will have some garbage value which make them point towards some random location, and we don't want this to happen. And for that reason only we call them as wild pointer. What is a wild pointer? Pointer which is just declared, it's not initialized. Those type of pointers are called as wild pointers. Now wild pointers should not be there into your program. And to tackle this, we will learn about another type of pointer, that is null pointer, which I am going to tell you about very soon. But in this example, you have to understand that this is a wild pointer. When you just declare a pointer, it becomes a wild pointer. Understood this? Now, because this is a pointer, and in this pointer we have stored nothing here, so it becomes a wild pointer. But in the next step, to clear this off, we need to point it towards the address of some other variable. In this case, we had this variable I, so we stored the address of I into this pointer PTR. So in this case, what happens is that this address 2179 gets stored inside this pointer, and as soon as this happens, this pointer starts pointing towards this value which is stored inside that variable, which is 50 in this case. And this is how pointers work, and this is how you declare a pointer, and pointer is declared, and this is the introduction to the pointers. So this is how pointer works. You can do a lot of things with pointers actually. And if we talk about the types of pointers, usually there are different types of pointers, but in general there are two major categories of pointers. And what are those categories? Typed pointers and untyped pointers. Typed and untyped. Basically, typed pointers are those pointers which will have some data type. Say for example, I created a pointer which is of int type, *int. This will point towards an integer type of value. If I have a pointer of type float, then it will point towards a float type of value. Okay. If I have a pointer which point towards a character type of value, like character type of pointer, it will point towards a character type of value. If we have a class pointer, then it will point towards the class object or the class type of value. Similarly, if I have a structure variable or structure type of pointer, then it will point towards that structure variable in this case. These are typed pointers. So specific type, those pointers which will have its own data types, those are called as typed pointers. Now this is one major category of pointers, typed pointers. On the other hand comes untyped pointers. Untyped pointers are those pointers which will not have any data type. But then what you will write there? You will write void. Void, and then you say star and then PTR. Well, this type of pointer which has the data type as void is also called as untyped pointer, or you can call them as generic pointers in this case. Understood my point? So there are two categories of pointers basically, typed and untyped. Typed pointers will have a data type with them which will allow them to point towards some specific value, but untyped pointers will not allow them. But basically untyped pointers will not have a data type in itself in this case, and that is why it is called as generic pointer or untyped pointers in this case. I hope so that this is very much clear. So how pointers, what are pointers and what are the types of pointers? This is very much clear to us. Now this was just the two major categories of pointers, but actually if I run this program that I have here in this case, as you see that this is the variable I, this is the pointer I have declared, because right now no value is present into it, it is called as wild pointer. Okay, and now I have stored the address. Now this is not any wild pointer anymore, it is just a normal pointer which points towards the address of I, and then I start printing it. Now you see that while I am printing it with %d. That means I want a number out of it, and I am using this star PTR. So when I use star PTR, there are two types of operators we use in pointers generally, that is ampersand and star. This ampersand is called as a referencing operator, operator. But this star is called as dereferencing operator. What it is called as dereferencing operator. And for that reason only, this is what you call as dereference operator. So when you print something like this, I want this access specifier as %d, which means number in this case, and it will dereference this pointer, means it will decipher the address of this pointer and it will give us the value. So this should print 50 in this case. And if I run this program right here, if I run this program right now, you can see that it will print 50 directly. You can see that it prints 50 in this case. So I hope that this is very much clear to everyone, right? Now we will see what are the different types of pointer. Now I told you that there are two categories of pointer, typed pointers and untyped pointers, but there are many different types of pointers basically. So we have wild pointers, then we have null pointers, null PTR, then we have dangling pointers, then we have double pointers, and today we will also see some working of void pointers as well, that is generic pointers. Okay, so let us cover all these topics in this video. Okay, so now the very first one is going to be wild pointer. You have understood, this is the wild pointer, basically a pointer which is not initialized, it is just declared. That is what you call as a wild pointer, and that's all you need to know. Wild pointer should not be available in wild pointer should not be there into your program, otherwise it will point to some random location which is actually existing, but it will point to some random location which is not good in this case. So wild pointer should not be present, and that is the reason why either you should allocate a memory, either you should allocate the address, or you should allocate it to null. And which brings us to our next pointer, and that is called as null pointer, right? So what is null pointer? When you have a pointer and when you initialize that pointer to null value, null, capital NULL, now this has become a null pointer in this case. So what it has become? This has become a null pointer in this case, right? So now why do we use null pointer? Null pointer is used to just deallocate or point a particular pointer which is pointing towards some random location to some particular null value. Usually null value means 0 in this case. Well, null is not a particular value, but when you want to just keep some random address, when any particular pointer point towards some random memory location, like for example wild pointer, you will have to initialize it to null, otherwise it will point to some random location and you won't know where it is going to store what. And for that reason only we use null pointers. But you see one thing here, that in this program I have written null pointer, I have declared a pointer here int star PTR and equals to, when I say null, if I try to print this, it will just say 0, it will not say anything in this case, because here I have given, you see, I'll run this program and I'll show you. See, when I run this program, what it says, it doesn't have anything. So basically this is undefined reference. This is what you call as undefined behavior into your program. And we don't know how our program will work. So in this case, what we will do, see, I have written it here for you. This code will likely result in an undefined behavior and the specific consequences can vary. The program might crash, produce an unpredictable output or behavior in an unexpected way. Undefined behavior means that the C standard does not specify the outcome and it is up to the compiler or the runtime. To avoid these situations, it is crucial to check if the pointer is a null before attempting to dereference it. And for that reason, I have written another program here. You see, in this case, when a pointer is null, you will check if the pointer is not equals to null, then you will print the pointer. Otherwise, you can just print the pointer is null. So basically, what did we learn from this is that null pointer is used whenever we want to point a pointer which is pointing to some random location with a null value. You don't want any pointer to point some random location. For that reason, to neutralize that pointer, we use null pointer. I hope so that this is also very much clear to everyone, right? So this was basic pointers. This is null pointers. There are two types of pointers I've already covered. Now the third one is going to be double pointers. Now you see I've written another program here for you to understand, and you see here one thing, that here I have created, so what, first of all we need to understand what exactly is double pointer. Double pointer is another type of pointer which we are going to understand. So in this case, what happens is, what is double pointer? So double pointer is a pointer, so we say double pointer. Double pointer is a pointer which points towards some another pointer in itself, basically. So basically, what is this? Say suppose this is a variable that you have created. So this is that I that you have created, and this has this value 50 in it. It will have some own address like this, and you have created another pointer in this case, you see, and that pointer is this pointer PTR. This one is single star PTR, and this pointer is holding the address of this pointer, which means 2179 is pointing, is stored inside this pointer, which is actually pointing towards this value. Let's say this address is 3179. So when you put more stars, when you increase the number of stars, that becomes a double pointer. And double pointer is actually used to store the address of another pointer. A single star pointer will point towards a normal variable, while a double star pointer will point towards a single star pointer. So basically when you want to store the address of a pointer in itself, that will be done by a double pointer. So double pointer is a pointer which holds the address of another pointer in itself, which allows us to dereference that particular pointer multiple times. So you see here, I can create another pointer now with double star dptr, and I can say, let's say it has 4178 value as an address. So in this case, what happens is that if I store this 3179, this double star pointer will start pointing towards this single star pointer, and this is going to point here. So when I'm printing it, you see, when I'm printing it, I'm saying %d as the access format specifier, and when I say double star dptr, star means dereferencing, right? So single star means I am dereferencing this pointer one time, which will give me the value 50. But if I dereference this pointer two times, it will again give me the value 50, because you see, this pointer is holding the address of this pointer is holding the address of this. If I dereference this dptr once, it will only give me the address of single star ptr, and for that reason only we use double pointers. Basically, double pointers are going to be a concept which is going to be used in data structures, and we will be using it a lot later on. Okay. So now if you see this example which I have written here, we will talk about this. Let's run this program and see. You can see that I have created a variable here, I equals to 50. Then we have created this star PTR here, and then this star PTR, then we have created 2 star PTR, and then we have created 3 star PTR, and then I have created the I have initialized this PTR to ampersand of I, dptr to ampersand of PTR, this PTR, double star PTR to ampersand of PTR, and then double star PTR, triple star PTR pointing towards the double star PTR in this case. And in this case, what happens is that we are just trying to dereference the pointers one by one. So single star, double star and triple star pointers we are dereferencing. So in this case, when I run this program, it will all print 50, 50, 50, 50, 50, 50, because here you see this is single star, double star, triple star pointers in this case, right? If I change this, let's say if I change this to a double star, then what will happen is when I save it and when I run this, you see that it will give me the address of the previous pointer, because we are only dereferencing it 2 times in this case. For that reason, we need to give more stars in this case, and when we run it, you see that it tells you about the values there. I hope so that this is very much clear. So this is your double pointers. And now in next type of pointers, we are going to talk about dangling pointers. Okay, so what are dangling pointers? So first of all, you have understood the concept of pointers. See, pointers are the variables which holds the address of another variable. So when you hold the address of another variable, it starts pointing towards the another type of memory location. Double pointer is a pointer which holds the address of another pointer, basically. So we have understood about that also. What is dangling pointer then? A pointer which points towards a memory location which is not even existing now. That means at some point of time, you have allocated some memory to this pointer which you have created, and then you have freed that memory. And when you free up that memory, what happened is that it started pointing towards some random memory allocation, and that is what we call as dangling pointer. A dangling pointer is a concept which your program should not contain in any scenario, and for that reason only we should know how to handle it. And to handle these dangling pointers are not good into your program, and to handle this dangling pointers, we need to initialize it to null pointer, as we have understood that null pointers are used to neutralize the pointers which holds the address of some random memory location or the non-existing memory location in this case. So this is another type of pointer, guys. And you see that here I have started by creating a pointer, and in this case we are dynamically allocating the memory here using the malloc function. And here I have said int star, so this is typecasting. So whenever you allocate the memory to a particular pointer, it returns you a void space, and that void space has to be typecasted into that type of value or that type of memory. And to do that, we use typecasting. So we will typecast that into that type of pointer, means integer type of pointer. We will typecast that into that type of value, and then we will give that. So this is your dynamic memory allocation. So I have dynamically allocated the memory to that pointer, and then I have printed that pointer. So in this case, it will print some random locations. If I run this code right now, so basically when I run this code right now, you see it is just printing some address which it is storing in this case. Okay, now you see that after allocating the memory, I'm using free function and freeing up the pointer. In this case, what happened? When I said free PTR, the pointer which was pointing towards some random memory location, now the memory is freed up. So what happened is that this pointer started pointing towards some random memory location, and for that reason it became a dangling pointer. So a dangling pointer is a pointer which will start pointing towards some random memory location. Not random memory location, but a non-existing memory location. When we are talking about random memory allocation, then it will become a wild pointer. So that is the difference between wild and a dangling pointer. A wild pointer will point towards some random memory location, while the dangling pointer will point towards the non-existing memory allocation in this case. So you should not have that dangling pointer into your program. And to dissolve this condition, we need to make it as a null pointer, hence assigning null value to a pointer, making it a null pointer. This will solve your issue. And at last, you see that when I run this, it prints 0 at last. Yes or no? Right? So in this case, this is how we are explaining you the dangling pointer like this. So basically, ultimately in a nutshell, dangling pointer is a pointer which is pointing towards some random non-existing memory location. The memory location is not even there, but still this pointer is pointing towards some non-existing place, and for that reason it is called as dangling pointer. To achieve dangling pointer, in this program we have allocated the memory and then we have deallocated the memory using free, and then we have just, to make it a normal pointer, we initialize it as null pointer in this case. Well, I hope that it is very much clear to all of you. This is the third type of pointer. So first one was wild pointer, second one was null pointer, third one is dangling pointer, and fourth one was double pointer. So there are 4 types of pointers which we have already covered. Now in this program, now in this video, let us talk about the last type of pointer, and that is void type of pointer. So just now I've explained you that void type of pointers are also called as generic pointers or untyped pointers. Now void type of pointers advantage is that you can point this particular pointer towards any type of value. Basically you don't have to give the data type, you just say void. It can store any type of address. It may be an integer variable address, or it may be a float variable address, or it may be a character variable address, or anything. Well, to use this pointer, what we do is we define it like void star ptr, and then we say, for example, in this example program only, I'm saying void star ptr. So this is void pointer declaration. Okay, so you just write void and then star and then ptr. Okay, and then what you do is you say int. I have created another pointer, so int star ptr1. So I'm declaring the integer pointer. Then I have another data, which is a normal variable, int data equals to 10. So basically this is integer variable initialization, and then what I'm doing is I am storing the address of this data into this integer type of pointer. So what I have done here is that I have stored the address of this data inside this pointer, okay, this ptr1 that you are seeing here. Okay, and now we are trying to allocate, so we are assigning the void pointer to the integer pointer. And how to do that? We are typecasting that pointer inside this ptr1, and this way we will be able to do the we are assigning the void pointer to the integer pointer. So we first, because this is a what? This is a void type of pointer. It will have a void type of memory allocation. You need to typecast it before you put it inside this ptr. So this ptr1 will now be stored inside this ptr, and then if I print the value of ptr1, it will be printed as, you see, 10. I hope so that it is very much clear to all of you, because the data was 10 in this case. Well, I hope so it is very much clear. This is your void pointers, and this is how you work with it. Now the last concept of this whole topic, pointers, is passing the pointers to a function. Basically we can achieve it by doing call by reference and call by value also, and in this case we will learn two things: how you can pass a pointer inside a function, and how you can do call by value and call by reference. Now let us understand about this here in this video. So first of all, we have a call by value. In this case, when you have a function, say for example in this program, what I have done is, in the main function I have created two variables, int a equals to 10 and b equals to 20. So a is 10 and b is 20. Okay, and then I have created a function here which is doing the swapping part. We all know how to swap. We use a temp variable, store a inside it, and then we use b inside a, and then temp back to b. This way the swapping will happen using the third variable temp. Now in this case, I printed first in the main function, I printed before swapping a equals to this and b equals to this, and printed the a and b value respectively. Then I have called this function right here, and I have passed the a and b. So 10 and 20 are passed, and then later on, after the function is called, I am printing after swapping the same thing. You see, when I run this program, what happens is that there is no swapping occurring. There is no swapping happening. So a equals to 10, b equals to 20, a equals to 10, b equals to 20, still after swapping and before swapping it is the same. Why this is happening is because, now this is something which is related to functions. If you don't know about functions, we have created a whole video on what exactly is function in our previous modules. So please go ahead and watch those videos first and then come back to this video, and you will understand about this. But if you are new to this video, if I want to explain you in short what exactly is a function. Function is a block of code which holds the does the specific task, whatever it is assigned to, and whenever you call it to do so, and that will do the job. So in this case, this function is doing the part of swapping, and the return type of this function is void. So it will not return any value back, and anyways you cannot return two values at a time from a function. And for that reason only, what we have done here is that because this is a void type of function, this function cannot tell the main function back that it has made the swapping changes. So what it will do is that it will not tell. It is actually, if you see, if I print this after swap right here in this function, it will actually print that it has been swapped, but actually it has not been swapped for the main function. In the main function, still A and B are still A and B, like that only. And why? Because while I was calling that function, I have just passed the values. This is called as call by value. In call by value, what happens is that generally whenever you pass any data directly to a variable inside the function parameters, the changes made by that particular void function is not returned back to the main function, and hence the changes made by the void type of function doesn't get reflected back to the main function. I hope so, it is very much clear. Now if I go back to call by reference, in call by reference, in the same program we are just using pointers, and now in this example actually I will show you how you will pass pointers inside a variable, inside a function. So I have created a function here called as void swap, and you can see that as a parameter only I have passed two pointers, int star a and int star b. So these are the two pointers which are passed into the function parameters. And now actually I am doing the swapping using those pointers. So basically what I did is I am using the third variable temp, and I am swapping the pointers in itself, not the value, just the pointers. So the whole pointer in itself is swapped. Okay. In the main function, I said a equals to 10 and b equals to 20, and I said printed before swapping a equals to this and b equals to this. And then I called that function, and because they are the pointers, in the call of that function, you will give the ampersand of the address of a and address of b. Well, I hope so this is very much clear, that whenever you give the pointers as a parameter of a function, in the arguments, you will pass the address of the variables in this case, in simple terms. Because this parameter will only hold the address, not the normal value. So you cannot just pass a, you have to say ampersand a. And for that reason only, I am passing two things, ampersand a and ampersand b. And then I am just printing after swapping. Okay. So in this case, what will be the result? It will just swap the two numbers. Before swapping 10 and 20, after swapping 20 and 10. Well, this is your call by reference. Well, I hope so that this is very much clear to all of us, right? If you have not understood the concept of call by value and call by reference, we have another video which I have already created, and I have explained everything about that in another video. So if you haven't watched that video, I will give the link of that video in the description as well as in the I button up there, and you can go ahead and watch that video as well. Okay. As of now, these are the topics which we had to cover, and this is what is pointer is. So pointer is what? It's a variable. So this was the program that we saw. So pointer program. So pointer is a variable which holds the address of another variable. Then this is null pointer. Null pointer is used to neutralize any pointer which is pointing towards some random location or a non-existing memory location. Double pointers are the pointers which holds the address of another pointers in itself. And dangling pointers are the pointers which point towards some non-existing memory location. While pointers, on the other hand, are the pointers which are non-initialized. They are just declared. That means they will have some garbage value inside it, which means they will point towards some random memory allocation, right? And then void type of pointers at last. So void type of pointer can point towards any type of pointer value basically. And at last we have done call by reference, where we have understood how you can pass the pointers inside the function's parameters and how you can use them. And we have understood about the call by reference also with this case. So in this case, where we are calling the function, we pass the reference, and the reference goes into the pointers as the parameters. Well, I hope so that this video is very much clear to all of you. And this way we have covered the syllabus for VTU scheme, the latest scheme that we were working on. And this is the pointers concept. I hope so that you have liked this video. If you have liked this video, tell us in the comment section below. If you have any doubts, tell us in that comment section below as well. And don't forget to press the like, share and subscribe button. And don't forget to press the bell icon so that you won't miss any future updates. And share this video to your friends and family. And that's all for this video. This is Ashank David signing off. I'll see you guys in the next one. Peace.